So here we are given an equation of a cubic polynomial and a general equation for a linear graph. As we can see, it's ax plus q and the highest power of x is 1. And now they say a, b with coordinates 2 and negative 16, and c with coordinates of 6 and 0 are the points of intersection of f and g. So these two graphs intersect 3 times at point A, B, and C. And so 8.1 says determine the coordinates of the turning point of f. And so to do that, we can make use of our knowledge from calculus. We know that if we take f of x and we derive it, so we are going to get 3x squared minus 10x minus 8. That will be our first derivative. Now we are going to take this first derivative and make f prime of x equal to 0 because the derivative of a polynomial is equal to 0 at the turning points. So then we just need to solve for x on this equation. And so from here we can just use the quadratic formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So let's remove this to get some space. And so if we substitute in, we will have minus into minus 10 plus or minus. So we have minus 10 squared minus 4 multiplied by 3 multiplied by negative 8. And then we just divide all of this by 2 multiplied by 3. And now we need to use a calculator. And so we just input all of this into the calculator. So one of the x values is equal to 4. Now we need to work out the second value of x. And so just go to our calculator and then we change that plus to a minus. And there we go. Our second value of x is negative 2 over 3. And now the last thing to do is to substitute in these x values into the original equation. So for x is equal to 4, we'll have f of 4 equal to 4 to the power of 3 minus 5 into 4 squared minus 8 into 4 plus 12. And for the other value of x, we have f of negative 2 over 3. So that will be equal to negative 2 over 3 cubed minus 5 into negative 2 over 3 squared minus 8 multiplied by negative 2 over 3 plus 12. So we just simply need to input these to our calculator. So this gives us negative 36. While on the other end, so let's do the substitution for that. So I'll just replace 4 with negative 2 over 3. So for this one, we are getting 400 over 27, which is 14.81. Therefore, we can conclude that the coordinates of the turning points here are going to be 4 and negative 36, and also negative 2 over 3 and 14,81. Now, in 8.2, we need to determine the other two x-intercepts of f. Well, that's because they have given us one of the x-intercepts. If you check here, the point C, the y value is 0, therefore 6 is the x-intercept. So lucky for us, we can use that as our reference. So this means that if we let y equal to 0 for f, we will have 0 is equal to x to the power of 3 minus 5x squared minus 8x plus 12. And we know that one of the values of x is equal to 6. Therefore, this means that the factor from which this was obtained should have been x minus 6. So that we know. And so now we need to determine the other two linear factors so that we can get the other two x-intercepts. Okay, and so here's the trick here. We know that here we are going to have a quadratic expression, and this quadratic expression must be such that if we multiply it by this linear factor, we are able to get the original expression again. And so to do that, we can start off by noting that if we multiply x with the first term of this quadratic expression, we must get x cubed. Therefore, the first term here must be x squared. And likewise, if we multiply negative 6 with this constant term of the quadratic expression, we must attain positive 12. So the constant term here must be negative 2. Okay, which means that we are only left with one term here that is unknown. So I'll just call it bx. We don't know what the value of b is. So that is what we need to determine. So whatever this term bx is, what we need to note is that if we multiply x with this term, we are going to get bx squared. Additionally, another x squared term that we can get when expanding this, it's when we are multiplying negative 6 by x squared. If we do that, we are going to get minus 6x squared. And therefore, if we now refer to our original expression, we can say that the term that corresponds to these two terms here is going to be negative 5x squared. So it means that if we combine these two terms together, we must get minus 5x squared. And so we just need to simply find the value of b here, such that if we sum up these two terms, we get negative 5x squared. So I'm sure that you can all agree that b must be equal to 1 because this will give us x squared minus 6x squared. And indeed, x squared minus 6x squared is going to give us minus 5x squared. So that's the value of b, so we can just input it in here. So we have x minus 6, and then we have x squared plus x minus 2 equal to 0. And so now we can just focus more on this quadratic expression here. So we need to find the value of x if x squared plus x minus 2 is equal to 0. And so we can just quickly solve this by factorization. So we open two brackets equal to 0, and so The first term is x squared, therefore we have x, and then the last term is negative 2, so we have 2 and 1, or 1 and 2. So the fact that this is negative, it means that the signs that will go into the brackets are not going to be the same, and the bigger number must have the positive sign. So 2 here must be positive and 1 must be negative, and therefore x is going to be equal to negative 2, or x is going to be equal to 1, right? Therefore, we can now conclude that the other two x-intercepts of f are going to be equal to negative 2 and 0, and 1 and 0. So that's how we can do 8.2. The next question, 8.3, is asking us to sketch the graph of f, clearly indicating turning points and intercepts with the axis. This is very simple. We need to sketch the Cartesian plane first. So I hope that you have taken note of all the answers from the previous questions, because we are going to need them here. So we've got the y-axis and the x-axis. Now, we do know the values of the turning points. In 8.1, we found that one of the turning points have got the coordinates of 4 and negative 36. So for that one, it means that if we have x equal to 4, the y value is going to be given by negative 36. And then the other turning point has got coordinates of negative 2 over 3 and 14.81. So this should be 14.81. Okay, so those are our turning points. And now the next step is to plot the intercepts. So we were given that one of the x-intercepts is 6 and 0. So maybe we can plot it here. So this is x equal to 6. And then from 8.2, we found that the two other intercepts are 1 and 0. So we'll also have a point there. And the other one is negative 2. So we can plot it here. So it's negative 2 and 0. And now additionally, although we were not asked in the previous questions, we also need to show the y-intercept. So we can easily say that the y-intercept will be equal to 12. No calculation required. So this graph is going to pass at a point, maybe we can say it's here, whereby the y value is equal to 12. So with all of these points, we should be able to sketch the graph of f. So it will look like this. This is a turning point. So if we can start from here, our curve must pass through this point, and then it is going to have a turning point here, and it has a y-intercept at y is equal to 12, and then it has an x-intercept at x is equal to 1, and then it has another turning point here at x is equal to 4, and then let's just join there, and then it has another x-intercept at x is equal to 6. And so this is how the graph of f would basically look like. Now, in 8.4, we need to determine the values of a and q. So here they are in the equation of g of x. So in other words, we just basically need to work out the equation of g. And remember that we're told that the points A, B, and C are all the points of intersection of F and G. So basically, it means that even G passes through these points A, B, and C. And as we can see from the equation they gave us, G is a straight line. So this is easy because A here is standing in for the gradient of this straight line. And since we have 2 points that we know, we can make use of them to just calculate that gradient. So A is going to be equal to the gradient, right? And we know that the gradient can be calculated by y2 minus y1 all divided by x2 minus x1. So let's just take C as x2 and y2 and take B as x1 and y1. So if we do that, then y2 here is going to be equal to 0, while y1 is going to be equal to negative 16. And then x2 is going to be 6, while x1 is 2. So this means that you are going to have 16 over 4. And therefore, this means that A is going to be equal to 4. And now, to calculate B, we can substitute the value of A to the equation of G. So we are going to have G of x is equal to 4x plus q. And now after this, we can just take any point here between B and C and substitute it in to G and just solve for Q. So I'll just take point C. So if we sub in point C, the y value is 0. So G of x is 0. And we see that x is 6, so we have 4 multiplied by 6. So 4 multiplied by 6 is equal to 24, right? And therefore, this means that Q is equal to negative 24. So that's how you can determine the values of A and Q. And so now we're only left with 2 questions, 8.5 and 8.6. And I have shown the graph that we had sketched from 8.3 here because we might need it particularly for 8.6. So in 8.5, we are asked to determine whether the graph is concave up or concave down at point B. So point B has got these coordinates of 2 and negative 16. So here you just need to remember that concavity can be determined from the second derivative of a function. So in the first question, we had already worked out the first derivative and we found that it was equal to 3x squared minus 10x minus 8. And now if we derive this again, we'll get the second derivative. And it will be equal to 6x minus 10, right? And now, in order for us to determine whether the graph is concave up or down at point B, we need to work out what is the value of the second derivative when x is equal to 2. So f prime prime of 2, so that will be 6 into 2 minus 10, which equals 2. So 6 multiplied by 2 is 12 minus 10, that is equal to 2. And therefore, it is greater than 0. That is what we are concerned with. The sign of the value that we get. Is it greater than 0 or less than 0? So in this case, since it is greater than 0, now you need to know this by heart. If the second derivative at a point is greater than 0, it means that the graph at that point is concave up. So we can conclude that the graph of f is concave up at point B. However, if the value that we had gotten here was less than 0, it would then mean that the graph is concave down. And now going to the last question, 8.6. So here we need to determine whether for which values of x is f of x greater or equal to g of x. So here, remember that we technically know the equation of g because we had calculated the values of a and q. Therefore, the equation of g of x is equal to 4x minus 24. Okay, so using this, we can actually sketch the graph of g of x on the same set of axes. So since C is an x-intercept, it's a point along the x-axis, and it's also a point of intersection for both f and g. It means that even for the graph of g, it will be its x-intercept, okay? And now the y-intercept will be minus 24. So we can plot that somewhere here if we imply that this is our negative 24. And so now we can just simply join these two lines. And so that will be essentially the graph of G. So that is our G, okay? So now this question is asking us a very simple thing. It's asking us whether for which values of x is the graph of f of x above the graph of g. So that is what this essentially means. Well, if we now go back to the two graphs here, we will see that there are certain intervals here whereby that's the case. For an example, at this point of intersection, we will notice that for values of x that are greater than 6, so in this interval, if x is greater than 6, so starting from here, the graph of f is indeed above the graph of g, right? And then in between this point and also this point of intersection, the graph of f is actually below that of g. So we need to know confidently whether what is this value equal to. Well, we're given some points of intersection here. So as you can see, whatever that value of x is between 1 and 4. So it must be this point B, right? So this must be 2. Okay, so between that value of x2 and this value of x6, the graph of g is in fact the one that is above that of f. So that one be part of our solution. However, x is greater than 6 is part of our solution. Okay, and so again, if we now examine the two graphs starting from this point of intersection and then we move to the negative x direction, we will find that the graph of f is again above the graph of g. However, it looks like at some point these two graphs are going to intersect again because the graph of f is going to continue to go down like this, while on the other end, the graph of g is also going to continue going down linearly in that manner. And so there we go. We are going to have another point of intersection. So this must be the point of intersection that they did not give us the coordinates for. That must be the point of intersection A. So this is not a surprising result. So we need to know what that is equal to as well. Because as we can see, so let me just label it as point A, because we say that between point A and point B here, the graph of f is above the graph of g. So we do need to know what the x value of point A is so that we can be able to take that as part of our solution. So that's one of the things that we need to do in this question. Of course, to determine the point of intersection, we are going to take the equation of f, which is x cubed minus 5x squared minus 8x plus 12 and equate it to the equation of g, which we have found to be 4x minus 24. So if we take this to the left-hand side, we are going to get x cubed minus 5x squared, and then minus 8x minus 4x is going to give us minus 12x, and then plus 12 plus 24 is going to give us positive 36. So all of that will be equal to 0. And now we are faced again with a challenge of solving for x for a cubic polynomial. Remember that we do know already two intercepts of this equation. So B, we know that x is equal to 2 there, and for C, we know that x is equal to 6. So both of these are already the roots of this equation. So we can employ the same strategy that we used before. So let's just note that we already know here that for this equation, x is equal to 2, and we also know that x is equal to 6. Now we need to know the third value, okay? So we already know two factors. We know that one of the factors will be x minus 2, while another factor will be x minus 6. And we want to know whether what is the other factor, going to equal to. So what I am going to do first is I am going to expand this. So this is going to give us x times x, which is x squared, x multiplied by negative 6, which is minus 6x, negative 2 times x, which is minus 2x, and the negative 2 times negative 6, which is positive 12. And then, therefore, this is equal to x squared minus 8x plus 12. So now we are going to take this and write it inside the brackets. And so this time around, we want to work out the last linear factor. So I'll just say x plus p equal to 0. And so basically, what we know about this value of p here is that if we multiply it with 12, we should get what? 36. So if you multiply 12 and p, so 12p must equal to 36. Therefore, p should be equal to 36 over 12. And so that is, of course, equal to 3. And so if p is equal to 3, this means that the x value here of the last point of intersection is equal to negative 3. And we do not have to worry about finding the y value in this case because we just need the x value in order to write our final answer. So this value here is equal to negative 3. Okay? And now we can say that another interval whereby the graph of f is above the graph of b, it's whereby x is between negative 3 and 2. These 2 points here. Therefore, to write the solution of this question, we would say that x must be greater than negative 3 or x must be less than 2. And we shouldn't forget the equal to. Or x must be greater than or equal to 6. And alternatively, you can of course also use the set notation. So you'd say that x is an element from negative 3 up to 2 with square brackets to show that negative 3 and 2 are part of the solution. Or x is an element from 6 up to positive infinity. So that is how you can answer question 8.6. Okay, so I hope that makes sense. Please let me know if you understand what we have done here. Otherwise, that is it for this video. See you on the next one.